Unit 1. Composition and structure of the atmosphere and distribution of temperature. Page number 1. Unit structure 1.0. Objectives 1.1. Introduction 1.2. Composition and structure of the atmosphere 1.3. Insolation and temperature factors and controlling distribution of temperature 1.5. Distribution of temperature on the Earth 1.6. Significance of atmosphere and temperature 1.7. Conclusion 1.8. Objective questions 1.8 questions 1.0 Objectives. Atmosphere is one of the most important components of our Earth. To study the composition of its atmosphere, to study the structure of its atmosphere, to study the factors controlling the distribution of temperature, to understand the variation in spatial distribution of temperature on the surface of the Earth, to know the significance of the atmosphere and temperature for living kingdom. 1.1 Introduction. The Earth's atmosphere is composed of gaseous suspended particles and water molecules. In the initial period after the formation of the Earth, the process of chemical and biological reactions on the Earth formed the gaseous envelopes encircling the Earth called atmosphere. The differences in the cooling and heating of the elements in the atmosphere due to incoming solar energy and outgoing heat radiated from the Earth helps to differentiate between atmospheric layers. 1.2 Composition and structure of the atmosphere 1.2.1 Composition of atmosphere. The gaseous envelope which surrounds the Earth is termed as atmosphere. Most of the atmosphere is confined to a thin shield around the Earth, with the pressure and density of air decreasing rapidly with altitude and gradually merging into the emptiness of space. 50% of the mass of atmosphere is within 5.5 kilometers of sea level. 90% is within about 16 kilometers of sea level, and 99.9% is below 49 kilometers. The atmosphere contains many gases. The atmosphere also contains water vapor and aerosols, small microscopic particles. Most of them are concentrated near the Earth's surface. This is due to the gravitational pull of the Earth and as the density of air is maximum. As we move above the surface of the Earth, the density of air decreases. It is important to note that 50% of the atmosphere lies below the height of 5.6 km and above 90% below 16 km. Only about 0.00003% of all the gases found in the atmosphere are beyond 100 km. Table 1.1 Composition of air in the Earth's atmosphere. Component. Symbol. Volume of dry air in percent. Nitrogen N2 78.08%. Oxygen O2 20.94%. Argon Ar 0.93. Carbon dioxide CO2 0.03. Neon Ne 0.0018. Ozone O3 0.00006. Hydrogen H2 0.00005. Krypton Kr trace element. Xenon X2 trace element. Methane CH4 trace element. Nitrogen and oxygen together make up about 99% of the volume of atmospheric gases. Some of the minor gases such as CO2 and O3 play an important role in the atmosphere. CO2 absorbs heat radiated by the Earth's surface during night and so is responsible for warming the globe. Or three gases protect the Earth by absorbing the incoming harmful ultraviolet UV rays from the sun. This composition of atmospheric gases remains the same up to the height of about 80 km. Therefore, the lower parts of the atmosphere up to 80 km are termed as the ionosphere. Composition of the atmosphere varies of 80 km of height, hence it is termed as heterosphere. The lower parts of the atmosphere up to 10 to 15 km contain water vapor. It is derived from the evaporation of and evapotranspiration. It is derived from the evaporation and evapotranspiration from water bodies, soil cover and vegetation respectively. The amount of vapor is determined by the temperature conditions near the surface of the Earth. As temperatures are higher near the equator and decreases towards the poles, the amount of vapor therefore is more near the equator and becomes less and will move towards the poles. In terms of vertical distribution of vapor content, more than 90% of the total atmospheric vapor is held up to an altitude of 5 km. Condensation of water vapor in the atmosphere is responsible for different types of water phenomena. The atmosphere also composes of microscopic elements such as dust and salt particles, etc. They are termed as aerosols. The hygroscopic salt particles absorb water and act as condensation nuclei in the formation of clouds. They also scatter solar radiation. The sky appears blue due to the scattering of violet rays of the incoming solar radiation. Structure of the atmosphere on the basis of the characteristics of the temperature and air pressure. On the basis of the characteristics of temperature and air pressure, the structure of the atmosphere is divided into four layers apart from the surface of the Earth. Figure 1.1. These are: first, troposphere. Troposphere means a region of intense mixing of atmospheric components where weather conditions are formed. Human activities are directly related to the weather conditions of this layer. It contains 75% of the atmospheric gases, water vapor, and aerosols. Hence, this lowest layer of the atmosphere is very useful to man. It is important to note that temperature decreases with increasing height at the rate of 6.5 degrees centigrade per 1000 meter 1 kilometer. This rate of degrees of temperature is called as normal lapse rate. Figure 1.2. However, it should be noted that there is a seasonal variation in the height of troposphere and changes from equator towards the poles. The average height of the troposphere is about 16 km over the equator and 6 km over the poles. The upper limit of the troposphere is called Tropopause. The boundary between troposphere and stratosphere, the next layer, is known as Tropopause. It is an inversion layer, that is, temperature does not decrease with increase in altitude in this layer. Tropopause acts as a lid of troposphere. Therefore, troposphere becomes a self-contained layer of atmosphere. Strong vertical convectional air currents are formed near the equator. Figure 1. Therefore, the height of Tropopause is 16 km at the equator, but it is only 8 km near the poles. Figure 1.4. Exosphere. Figure 1.1. Structure of atmosphere. Ionosphere, over 50 km. Mesosphere, Troposphere 18 km. Tropopause 14 Stratosphere 50 km ozone layer. Structure of figure 1.2 normal lapse rate. (30°C to 6.5°C, 23.5°C, 23.5°C minus 65°C equal to 30°C, 36.5°C. 1 kilometer height, 2 kilometer mountains. Code path J, convectional currents. Land, wind, temperature, land, wind, air currents, descending air currents, descending air. Land, wind, ascending air currents, descending air. Figure 1.4, Tropopause. Equal to 16 kilometer. 8 kilometer north pole. 7. Stratosphere. Stratosphere extends from Tropopause up to the height of 50 km. There is an absence of storm or changing weather conditions on the water vapor. Temperature remains constant at the lower part of the stratosphere, but it increases with increase in height. The lower part of the stratosphere is used by jet aircraft. The ozone layer is mainly found in the lower portion of the stratosphere from approximately 20 to 30 kilometers above Earth. Its thickness varies seasonally and geographically. Ozone layer in this region absorbs the harmful ultraviolet rays of the sun from reaching the Earth. The composition of the stratosphere also changes with latitude, that is, it begins with 9 km above the poles, 10 or 11 km in the middle latitudes, and 16 km at the equator, and extends southwards up to 60 km. It is a zone of dry, thin air, cold and clear with a horizontal temperature gradient, and in polar regions the temperature is 40°C, 6°C, but near the equator it ranges from 62°C to below 75°C. In the middle latitudes it remains steady at about 45°C. Figure 1.5. No weather occurs in the stratosphere. Air temperature slowly increases with height in the stratosphere. Figure 1.1. Temperature changes in the stratosphere with height. Temperature height up to 12 km Tropopause. Temperature above 12 km remains stable. Temperature increases with the increase in height. 50 km stratosphere. Temperature decreases with increase in height. Figure 1.2.3. Role of ozone layer. Concentration of ozone O3 is found in this zone. Between 25 to 50 km, ozone is made up of 3 atoms of oxygen O3. Ordinary oxygen molecule is made up of only 2 atoms O2. Oxygen molecules is broken into 2 atoms by UV radiation. Figure 1.6. Therefore, the unstable atom combines with other molecules of oxygen O plus O3 equals 3. Thus, O3 is or ozone is formed. Ozone molecule may split into two molecules and the unstable oxygen atom by the UV radiation. This conversion of ozone to oxygen and oxygen to ozone utilizes much of UV radiation. Thus, the amount of UV radiation reaching the Earth's surface is considerably reduced. Excessive quantity of UV radiation reaching the Earth's surface may create problems such as blindness, skin cancer, and can even damage vegetation. Effect of Figure 1.6 Effect of ultraviolet radiation. Its surface people when ozone layer is more reduced proportion of ultraviolet radiation before passing in the past UV radiation passing. Ultraviolet radiation at present increases the proportion of ultraviolet radiation on the Earth's surface. Ultra Figure 1.7 Ultraviolet radiation and ozone layer. Ultraviolet radiation to make oxygen to ozone, ozone to oxygen. Mesosphere. Mesosphere lies above stratosphere and below the thermosphere. It extends from above 50 to 85 km from the Earth's surface. Temperature in the mesosphere decreases with the coldest temperature in the Earth's atmosphere, that is about minus 90 degrees Celsius, is found near the top of the mesosphere. Mesopause is a boundary that lies between mesosphere and thermosphere. Various types of waves and tides in the atmosphere influence the mesosphere. These waves and tides carry energy from the troposphere and the stratosphere upward into the mesosphere, driving most of its global circulation. Third, thermosphere. Above the mesosphere, in the thermosphere and beyond, gas particles collide so infrequently that the gas becomes somewhat separated based on the types of chemical elements they contain. The thermosphere lies between the mesosphere and the exosphere. It extends from about 90 km to between 500 and 1000 km geographically above the Earth's surface. Temperature increases sharp, the temperatures increase sharply in the lower thermosphere, that is from 200 to 300 km height. The density of air is very low in the thermosphere. Solar activity strongly influences temperature in the thermosphere. The aurora, the southern and northern lights, primarily occurs in the thermosphere. Charged particles, electrons, protons, and other ions from the space collide with atoms and molecules in the thermosphere at high altitude. Charged particles, electrons, protons, and other ions from the space collide with the atoms and molecules in the thermosphere at high latitudes, exciting them into higher energy states. Those atoms and molecules shed this excess energy by emitting photons of light, which we see as colorful auroral displays. Tropopause is the boundary that lies between the thermosphere and the exosphere. The Earth's atmosphere also includes the region of the atmosphere called ionosphere. The ionosphere is a region of the atmosphere that is filled with the charged particles. The high temperatures in the atmosphere can cause molecules to ionize. The ionosphere represents less than 0.1% of the total mass of the Earth's atmosphere, but is extremely important because upper atmosphere is ionized by the solar radiation, where the sun's energy is strong at this level, which breaks apart molecules. Different regions of the ionosphere make a long-distance radio communication possible by reflecting the radio waves back to the Earth. Figure 1.8 and Figure 1.9. Figure 1.8 Broadcasting of radio or TV waves. Signal tower to the D layer and E layer and F layer at triangle. Figure 1.9 Greenhouse effect. Glass house plant. Greenhouse effect. Greenhouse. When solar rays fall into the glass house plant, heat is trapped and it produces greenhouse. It's called greenhouse effect. On the Earth, like that, the Earth day sunrise falls on the Earth before falls. The shortwave radiation creates that on the atmosphere. Day isolation, incoming solar radiation, and night long wave radiation outside heat raised by the Earth. 1.10 Vertical distribution of temperature. Temperature in degrees Celsius. You see on one hand the direct sunlight falls on the 80 and diodes activity and lost activity reaches to the 10 degrees. For exosphere, the exosphere is the outermost region of the Earth's atmosphere and gradually fades into the vacuum of space. Air in the exosphere is extremely thin or almost airless. The lower boundary of the exosphere is called the exopause. At this altitude, barometric conditions are absent. Atmospheric temperature becomes almost constant above this altitude. Exosphere lies at a height of about 500 to 1000 km from the Earth's surface, depending on the solar activity. Invisible, the exosphere covers distances where the particles are still gravitationally bound to Earth. That is, particles still have ballistic orbits that will take them back towards the Earth. The exosphere is a transitional zone between Earth's atmosphere and space. Check your progress. Question 1. What is atmosphere? Question 2. What is the composition of atmosphere? Question 3. Give the structure of atmosphere. 1.3 Isolation and temperature. The heat issued from the sun travels in the form of short and long wave radiation. The temperature of the atmosphere is determined by the rate of isolation, that is, the amount of heat received from the sun by the Earth, which is released by the Earth long wave radiation that heats the atmosphere from below. The atmosphere contains various greenhouse gases such as carbon dioxide, ozone, and water vapor that absorb outgoing heat released by the Earth after sunset. This phenomenon is termed as greenhouse effect of the atmosphere. Greenhouse is a glass house constructed normally in the temperate belt region of growing plant. As greenery is inside house, it is termed as greenhouse. Temperature inside the greenhouse is more in comparison of outside the greenhouse. This is possible due to dual properties of glass. Glass is transparent and it is a bad conductor of heat. When the solar radiation enters into the glass house, that is the greenhouse, without in heat obstruction, there is a converter into heat. This heat is trapped inside the glass house. It is important to note that atmospheric gases cannot prevent isolation, short wave radiation from reaching the Earth, and so the Earth's surface gets heated from above. However, the heat received by the Earth is released in the form of long-wave radiation that is absorbed by the atmospheric gases. Figure 1.11. As a result, the atmospheric temperature is raised. This is termed as greenhouse effect of the atmosphere. Figure 1.11. Magnetic waves on the short and long wave. When the sun rays falls on the earth, it creates short wave, and when it reaches the absorption, Earth releases long wave. Lava. 1.4 Factors controlling distribution of temperature. Temperature of different places on surface of the earth is not same everywhere. This is because the amount of insolation received at the surface of the earth is controlled by the angle of the sun, the state of the atmosphere, altitude, and geographic location as explained below. First, latitude. Solar rays are vertical within the tropical belt, that is, from the Tropic of Cancer and to the Tropic of Capricorn. Vertical rays are concentrated over smaller surface area on the Earth as compared to the oblique solar rays. Figure 1.12. Similarly, the resistance offered by the aerosols and other elements in the atmosphere is less in the case of vertical solar rays than the oblique solar rays. Intensity of solar radiation decreases due to the resistance offered by the atmosphere, that is, due to reflection, diffusion, scattering. Due to these two factors, areas receiving vertical solar radiation record higher temperature than the areas receiving oblique solar radiation. Figure 1.4 Temperature belts. Polar belt cold 90 degree south latitude. Temperature belt mild temperature 6.5 degrees south latitude. Tropical belt high temperature 0 degree latitude 23 and half south latitude. Equator 0 degree latitude. Uh, Temperature belt. Figure 1.13 Vertical and oblique rays and heat received. Oblique rays spread over large area have heat is distributed so it is less. Sunrays concentrate over small area and release more heat. Oblique rays. Generally, temperature decreases away from the equator towards the pole. Figure 1.4 shows the temperature decreases from the equator towards the pole. Uh, See the earth upside is not pole and downside is not pole. And it is the equator. Temperature decreases as more away from the equator towards the poles. Altitude. Temperature decreases with increase in the altitude from the Earth's surface. Solar rays pass through the atmosphere in the form of short-wave radiation. Earth's surface is heated and then it emits heat in the form of long-wave radiation. Earth radiation. This long wave is absorbed by the water vapor and enters into the atmosphere by the process of evaporation. From the Earth's surface, CO is added to the atmosphere by the processes like burning, combustion, etc. As the concentration of water vapor and CO2 is more near to the Earth's surface, the lower layers of the atmosphere absorb more heat. As we move towards higher altitude, the amount of water vapor and CO2 decreases, so the capacity of the atmosphere to absorb heat. As the temperature decreases with increase in the altitude. Figure 1.15. Figure 1.15. Temperature decreases with increase in height. Sea, land, land surface at above land surface 25 degrees and above land surface 20 degrees. Highlands and the mountain and surface 15 degrees Celsius. For distance from the sea, temperature characteristics of land and water are different. Land is heated more than water due to solar radiation during daytime, as solar is heated and absorbed and it is more slowly by water than by land. Water retains heat for longer time and hence land becomes cool while water remains warm during the night time. This difference in the heating properties of the land and water is main cause of land and sea resources in the coastal areas. Difference in the maximum and minimum temperature is less in the coastal areas, but it is more in the interior parts of the continent due to the absence of water. Figure 1.6. Figure 1.16 range of temperature increases with distance from the sea towards the land. Range of temperature 2 degrees Celsius to 20 degrees Celsius. Fifth angle effect. The effect of solar rays on land in the temperate region, south-facing slopes of the mountains in the temperature region of south northern hemisphere and receiving more sunshine insolation than the north-facing slopes. Hence, the vegetation and settlements are found on the sunny slopes, south-facing, which are termed as moderate, north-facing slopes of the mountains in the temperate region, which remain in shade, are known as back slope. This effect of slope on the temperature is termed as the aspect effect. Figure 1.17. Figure 1.17. Aspect effect. Slope facing sun is warmer. Mountains North Pole, tropical belt, equator, tropical belt, South Pole. Sunrise. North side back slope cold. South side aspect slope high temperature. Ocean currents. Fifth. Ocean currents. Warm ocean currents are responsible for increasing temperature of the surrounding region. Example, coastal areas of West Europe remain warm due to the Gulf Stream of the Atlantic Ocean. Similarly, cold ocean currents reduce temperature of surrounding areas. For example, a Labrador cold current near the Greenland. 6. Local events. Warm local events increase temperature of the surrounding region, and cool local events reduce the temperature of the surrounding region. 7. Nature of cold cover. Solar rays are reflected back due to the cold cover. Diffuse solar radiation reaches the surface due to the presence of cold cover. Earth radiation is reflected back to the Earth due to cloud cover. Nature of cloud cover. The solar rays are reflected back due to the cloud cover. Diffuse solar radiation reaches the Earth's surface due to the presence of cloud cover. Earth's radiation is reflected back to the Earth due to the cloud cover. Difference in the maximum and minimum temperatures listed at the equator due to constant cloud cover, but desert areas record extremes of temperature due to the absence of cloud cover. Figure 1.8 of cloud cover and temperature. Rare cloudy weather, temperature less clouds, day reflection. Earth radiation reflected back, warm air, close night moon. On 19. The effects of cloud cover on temperature. Desert landscape. Day, clear sky, no obstruction, hence high temperature. Sand dunes. Night, no obstruction as clear sky and low temperature. 8. Duration or length day. Duration of a day is more during summer than in winter, hence more solar radiation is received during summer than in winter, since temperature is in summer and less in winter. Check your progress to name the factors controlling distribution of the temperature. To explain the inversion of temperature in the atmosphere, you write a note on ozone layer. 1.5. Distribution of temperature on the Earth. Distribution of the temperature is explained as under the vertical distribution of temperature. The distribution of the temperature varies vertically as well as horizontally on and above the Earth's surface. Generally, the temperature goes on decreasing with increasing altitude from the sea level. It is due to two reasons. First, the atmosphere near the Earth's surface absorbs most of the long-wave radiation, thus the air gets heated from below. That makes air to warm up and so it rises up. In this process, the evaporates of warm air, it gets expanded, that releases the heat, and so the temperature goes on decreasing as we move upwards. Secondly, the greenhouse gases such as carbon dioxide and water vapor are more near the surface of the Earth and become thinner. With increasing its lower atmosphere is warmer, while temperature becomes cooler with increasing height of the temperature, which is limited only to the lower region of the atmosphere. However, at times there is inversion of temperature in the vertical temperature distribution. It occurs when there is the absence of winds blowing, the sky is clear, winters are long, air is cold and dry, and the land surface is covered with snow. Inversion of temperature. Temperature inversion is a condition in which the temperature of the atmosphere decreases with altitude in contrast to the normal decrease with altitude. When temperature inversion occurs, cold air underlines warmer air at higher altitudes. It may lead to different weather effects such as pollutants. Azotes pollutants may get trapped below the inversion as the sky becomes very icy, causing respiratory problems. It usually occurs in high-pressure zones where the air is gradually sinking down in the lower atmosphere. The horizontal distribution of temperature on the Earth. The horizontal distribution of temperature across the globe is governed by various factors. These are absolute location, latitudes and longitudes, relative location, maritime, continental, time, season, duration, and intensity of the sunlight received, location, equatorial to polar, day and night, soil type and vegetal cover, relief, water bodies, winds, ocean currents, and cloud cover. This horizontal temperature distribution can be identified across the globe with the help of isotherms for the months of January and July as best example. The solar rays are perpendicular on the lower latitudes and becomes landing as we move towards the higher latitudes. As a result, temperatures are higher in the tropical region and lower in the polar region. Tropic of Cancer 23.5 degrees north latitude and Tropic of Capricorn 23.5 degrees south latitude. The upper latitude limits of perpendicular solar isolation receiving maximum heat from the sun. Isotherms are imaginary lines drawn with the areas having same temperature. These isotherms generally run from east to west and are parallel to the latitudes. These isotherms are irregular in the northern hemisphere due to more land surface with its diversity, whereas they are more uniform in the southern hemisphere due to more water surface with less diversity. Variation in temperature is rapid in the higher latitudes since isotherms are closely spaced, whereas temperature variation is relatively slow in the lower latitudes. Therefore, the isotherms are widely spaced. Isotherms may for the months of July and January experience the given concept of horizontal distribution and of temperature. 1.6 Significance of atmosphere and temperature. The existence of life on the Earth is because of the gaseous envelope of the atmosphere that provides warmth by trapping heat released by the Earth and other necessary gaseous elements, dissolving in rainwater, reaching the Earth's surface to enter into ecosystem. Advantages of the atmosphere. Some of the advantages of the atmosphere are as follows. It provides oxygen required for our survival as well as for the other forms of life. It provides carbon dioxide to plants for their survival. The atmosphere controls the temperature of the Earth, which is essential for the existence of various forms of life in the environment. Without the atmosphere, the temperature of the Earth would have increased to more than 200 degrees Celsius, which is certainly not suitable for the environment found on the Earth. The growth at the atmosphere ozone layer protects us from the harmful effects of ultraviolet radiation, which is a part of the solar radiation. Thus, weather and climate are the terms used to indicate changes in the atmospheric condition. Our daily and annual activities are associated with weather and climate. 6. It protects us from the harmful meteors which are attracted towards the Earth. Many of them are burned down as they enter into the Earth's atmosphere. 1.7 Conclusion. First, the vertical distribution of temperature, pressure, density, and composition of the atmosphere constitutes the atmospheric structure. Spatial variation and the distribution in temperature is determined by the season, its geographical location, and the time, daytime or nighttime, and its distance and height from the sea. Second, a mixture of a number of gases is termed as air that constituents abundantly molecular nitrogen and molecular oxygen O2 and Is a mixture of a number of gases, strong gas, air that constituents abundantly molecular nitrogen, wind to molecular oxygen, O2, and L. A mixture of a number of gases, strong gas, air that constituents abundantly molecular nitrogen, into molecular oxygen, O2, and a little amount of the inert gas, argon, air. The together constitute 99.9% of the mass of dry air. This ratio of the number of each molecules is nearly stable to up to a height of about 80 to 90 kilometers from the Earth's surface. Water vapor H2O and carbon dioxide CO2 are other important gases that absorb the emit long-wave radiation, and ozone O3 gas that absorbs ultraviolet radiation from the sun as well as some long-wave radiation from the Earth. The distribution of these gases therefore reflects the vertical temperature distribution. The temperature thus cools with the height of the throughout the troposphere, but it then warms throughout the stratosphere only to cool again through the mesosphere. Finally, it heats up in the thermosphere and exosphere. This distribution comes about through the changing interactions among short-wave radiation from the sun, long-wave radiation from the earth, and various gases in the air. Question 1.8 questions. Explain the decomposition of and structure of atmosphere. Draw suitable diagram. 2. Discuss the factors determining distribution of temperature. Draw suitable diagrams. Describe the horizontal distribution of temperature. Draw suitable diagram. To explain the vertical distribution of temperature, draw suitable diagram. 4. Examine the importance of atmosphere and temperature, giving the suitable examples. References 1. Copernicus in data of 2015 Physical Geography FYB Assumption 197 Set top lists private limited numbers. 2. K. Siddhartha 2001 Atmosphere, Weather and Climate Australia Publication Limited New Delhi. Chad Ranjit Singh 2005 Geography Data McGraw-Hill Publication New Delhi. 4. Savinder Singh 2001 Climatology Prayag Pustak Allahabad.